So lecture number 17 in the technology management section is on an introduction and overview of cloud computing. What I want to do is give you software as a service and the cloud architecture from a high-level business perspective to make some sense out of some words that are commonly misused. The funny thing is that nothing actually is new. That cloud computing has been around for centuries. It's called computer networks. It's called networking. It's called making a client and a server or distributing out the computing resources over multiple servers. It's regular old platform stuff we've been working with, but the architecture is different. So the architecture is the new part. So cloud computing by definition, if you were answering this question on the final exam, you're going to want to know what cloud computing is about. So if you pick this one, definitely pay attention and maybe do some research on your own. In fact, what you're going to end up having to do for most of those questions is do a little bit of prep work, preparing, and doing a little bit of research on your own. So, as I mentioned before, the exam's not about rote memory, it's about preparation. The people who are going to do the best on it are the ones who are going to take this next week and actually research those topics and think about the topics and come up with an answer. And then when you come in, don't come in like, without looking at it. Review the stuff before you walk through the door so it's fresh in your head. That's how you're going to do the best, I think, on it. So, all right, which is different than a multiple choice test. Multiple choice test, you just come in and you just go click, 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 click. But it's harder to get it right. So, cloud computing is a general term used to describe a new class of network-based computing. Now, it takes place over the internet and basically is a setup from a utility computing. Well, actually, it is a step up from that, and it is an abstraction off of utility computing, which I would say is probably why most people think there's nothing new about cloud computing, including myself. And why they call it a cloud, I don't know. When I think about a cloud, I think of like something you can't see through. It's not transparent. On a clear day, you look up, there's no clouds. You can see everything. It's bright and beautiful, nice. And then you put the clouds in there, and all of a sudden it gets muggy, it starts raining, and it's like a negative, the cloud. The cloud is not a good thing, but they used it. So, but apparently it has the exact opposite meaning in terms of its computing implementation. The cloud brings everything together and creates transparency, invisible lines between all of the different networks. But it's the exact opposite of what you'd think when you would imagine a cloud up in the sky. I always think, I can't see through it. It's dark, it's black, it's colored. It's kind of like the black box, white box kind of scenario. So in other words, it's a collection of grouping integrated network components, hardware, everything, called a platform. It's on an infrastructure or a platform. It uses the internet, obviously everything uses the internet these days, for communication and transport, provides hardware and software networking services to clients. Imagine a bunch of servers all put together on a common platform and transparently connected together. When I say transparent, it means that we're working with multiple servers as one unit. Instead of thinking, I'm going to connect to a server, and then I'm going to connect to that server over there, and then I'm going to connect to that server over there, and that one over there. I'm connecting to the cloud, and the cloud has everything in it. So it's a multiple server connection. And each server can be designated for multiple different jobs. We can have application servers, we can have storage servers, we can have resource servers, all sorts of database servers, all sorts of different components that we can put in there and all branch it out. And then we can provide computing services to economies of scale. We can make huge environments available for massive computing efforts by many people, and we can all share our data together. So the biggest topic around these days is the cloud security. In fact, I think I2 actually teaches classes in cloud computing and cloud security as well. And the biggest thing about cloud security is that it's kind of a nomenclature or whatever, it's kind of like an oxymoron. Security, cloud. How does that work? We're going to share everything, but we're going to make it secure. Okay. We're going to have transparency among all the different servers, but we're going to block off each one of them. Okay. It doesn't really work. So a lot of research has been done, a lot of issues related to security. In fact, I think the biggest problem right now is security. So there's you know, huge companies that have cloud computing as part of their backbone services. Google obviously is one of them. You know, Amazon, huge cloud company. Actually, Amazon is a big cloud provider as well, services. Rackspace, there's a lot of players in this that provide computing services. And they just sell you space or time or bandwidth, you know, and then basically you're buying, what are you buying? You're buying everything. You're buying the platform. What do you get? Everything. You want a database? Here's a database. You want this? You get that. You want programming tools? Here you go. You want a website, web tools? Here you go. And you just pay by the month. So it's kind of like other services, like as an example, on Salesforce.com. Good choice. Actually runs off of cloud. So we have software that runs off of the cloud. We have hardware that we can sell, rent out to people, lease out to people, and services. So the platform hides the complexity and the details of the underlying infrastructure, users, and applications by providing a very simple graphical API or application programming interface to work with it. So that's the definition of cloud in terms of, and it really is utility computing, an extension on that. So in addition, the platform also provides demand for services. Well, actually, Salesforce.com is a cloud computing service. One of the biggest ones, actually, that's most business people use these days. We also have database services. In fact, our EMS runs off of a cloud service. I think we're using, well, we were on Amazon for a while. We're not, I think we're on Rackspace right now. I think we're going back to Amazon or something. I don't know. We can switch. We can go to different clouds. Who cares? You just move the application over. But what you get is bandwidth. You get multiple server storage capabilities. You get, you know, application software services and things that work with it. And you provide a huge application that everybody connects to and everybody uses, and it kind of is the framework for, well, it's the framework for ITU, actually, for student services. So it's a pay for use and needed. So it's a scale up, scale down. So it actually comes around and says, well, you know what, if you don't need that much in your startup company, why buy a big old server system? Why install the hardware yourself when you don't need to? So you subscribe to cloud services and you grow it. You grow the services, you increase your policy. Kind of like cable service, actually. If you want to save some money, just take off all your premium channels. Go back down to basic cable. And then you'll be saving at least $100 a month on that one. So, because that's just scaled. It's a scale up, scale down kind of service. You have basic, you know, this plan, that plan, that plan. Well, you buy cloud services the same way for a company, actually. So hardware and software services are available to general public, enterprises, corporations, and businesses. So actually thinking about cable television, one of the interesting things is the whole DVR concept, actually. And also providing cable networks over cloud services, which is actually kind of an interesting concept. If you're going to stream content, most of your, if you've ever experimented on it with internet television or internet movie stations and the whole, all those, a line of products out these days that facilitate that. It makes your TV smart. You run the internet through your TV. Most of them are cloud-based services and are going in and they're pulling everyone watching the same copy of everything and they're streaming it from one server. So it makes it efficient. So if you're a Comcast subscriber and you're using the DVR services to record something, you're not really recording anything. Everything is already recorded for you. You're just selecting what's available. And you pick it, and you go, oh, I want that. Everybody else has the same thing. So before we had this, which is, this is really, okay, this is an example of a real life scenario. Before we had this, people used to put these TiVo box. Everyone remembers TiVo, maybe, or maybe not. If you're not from this country, you probably have never heard of TiVo, or maybe you have. They were little DVR boxes. Actually, some cable prescribers, I think Dish still does this, gives you a box, and on the box you get like a 200 or a 300 gigabyte drive. And you actually, just like the old VCR, you stuck a tape in and you pressed record. And then after the show was over, you pulled the tape out and put it back in, play, or whatever. And you played it and it was recorded on that media. Waste of space. Waste of space for DVRs, waste of space for VCRs, or DVDs, for all that. Actually, there's no reason why to have any of that stuff anymore. Because what you end up with is the cable company itself using a very good bandwidth, very good high quality HD recording, not the interferences of it going over a communication line to begin with, because your copy isn't going to be that good. Not as good as the cable company. If you record it at the source, keep it at the source, play it to the people. So now you don't have a DVR anymore. You have a service. It's a cloud service that goes to the cloud and says, hey, on channel 5 on this day there was this program. Go find it and bring it to me. Here it is. And everything is archived and everything's stored. You only have one copy of it instead of every single household recording the same show and playing back their own individual copy of it. Not only that, but you can protect who's got it, which is what's happening with software right now. So Microsoft was the first one to come out with the 360 Office. The 360 concept being you're not running all of it from your local computer. So when you install it, you're subscribed to a Microsoft service. And the service, this is the future version of this. The run right now actually does get installed. But the concept is run it as a service. So this is software as a service, or SaaS as a concept, where you put it in a cloud, you make it the Microsoft cloud. And your computer transparently connects to this service, and it provides the necessary components to make your software work. If you're not connected, your software is not going to work. And then your license is with your service contract. So you can't pirate this. You can't run it illegally. Same way you can't download movies illegally anymore either. If you run it through a cloud service and you make people like Netflix or like Amazon or one of these other companies that sell you subscriptions, and you go through the subscription, well then you're doing things legally. You go around it the other way, well pretty soon in the next 5 years or so it won't be available the other way because it's all being privatized. It's all being loaded into content clouds. So you can't find it. You're not going to find it on some lame website from some guy who's been scanning in DVDs and recording it. I mean, you'll still have a little bit of that crap out there, but you won't have everything. So books are actually doing the same thing as well. We still have PDFs all over the place, which is totally wrong. It should run from a cloud. It should run from a streamed service. So you connect to it. You say, where's that book? Here it is. Kind of like iTunes runs. You lose your iTunes account, you lose your books. Here it is. Now we're going to stream it to you. You can read the book. You can use it. You bad account, you're disowned, you're blacklisted, no more book. So, but now we have things that, copy it locally. We can copy music locally. We can copy books, DVDs, multimedia locally. But nobody wants to copy it locally. What are you going to copy it locally for? If everything is off of a cloud, we don't have to have local, going back to what I was saying about thin clients and thick clients, fat clients. We don't have to have fat clients anymore. We can have thin clients. The only problem with the entire scenario, and the only problem with going cloud computing for everything, is that we have to guarantee that everybody has internet access. And we can't do that. So until everybody has internet access, this is not going to be a reality for the mainstream. It will be for certain services like cable and telephone and stuff, but not for everything else. So cloud summary, what we're looking at is an umbrella term used to basically describe internet-based development and services. So a number of characteristics including cloud data, remotely hosted services, unambiguous services or data that are available from anywhere, which is actually kind of interesting. In fact, if you look at cloud-based email like Gmail as an example, you can get it from your mobile phone, you can get it from your tablet, you can get it from your computer. It's all the same mail. Believe it or not, in the old days, people used to have to go through and say, oh, I already read that one, delete it. I read that one too, delete it. Now you delete it, deletes it everywhere because it's now on a server. So we have application, platform, and infrastructure in terms of the components that make up this cloud. Yes, we have cloud architecture here. Now this is not a replacement for taking an entire course in cloud computing. This is just an introduction to engineering managers and to business people about, as an example, what are some common components that make up the infrastructure? Well, everything is run on hardware. So we still got those old servers that we had before. No new hardware. You could basically put cloud platforms on existing servers. And then we have the platform as a service component, and then we have the service value networks. This is your cable provider. This is your cable service. This is the company that owns the cable service and our servers that are running it for you. So it's a kind of an interesting architecture. It's layered, as we see before. These clouds are layered one on top of the other. And there's a transparent connection between all of them. So abstractly, it's all working together. So you can go through. And then you have different cloud computing layers. And here's an example of some different layers. Application services. So that's Google Apps, Salesforce, Quicken Online. Cisco runs that way. And then we have the application platform. Well, that's the app engine. Actually, that's the mapping engine, the app engine, the GIS engine, all of the different services that you get through the APIs for all the programs for mobile app development and for, general app development. And then we have the server platform. Well, that's the host itself, Splice host, EC2 if they're still around, right scale. And then we have the storage platform, Amazon, S3, Dell, Apple. And then here's our little overview of the service layers. So we have application focused versus infrastructure focused, and then all the layering that would occur. This is the traditional model. The layering has changed over the last year or so. But as an example, we have our PayPal as a service that runs. So actually, the funny thing is in maps like that, it runs actually over many different platforms. PayPal. You can use PayPal on a mobile device through another cloud service connection. You can do it through eBay. You can do it through Amazon. So it's very versatile as a service. That's a service. And then the application itself, the software that's providing you the cloud, Microsoft Online. My Mobile, I think, or iMobile or something like that is the newest one for the Apple platform. So that's a cloud application. Mobile Me, I think is what I'm talking about. It's kind of old actually at this point. All right, so basic cloud characteristics. There's no need to know in terms of the underlying details of the infrastructure unless you want to build the infrastructure. Then you take, as an engineer, you would take a development course in cloud computing. So what you're looking at is the application interface for the most part, and the APIs that work with the application interface. And a lot of your mobile app developments and your application developments, even through .NET actually these days, is working with APIs that work with cloud services. That's how you're going to share data among different platforms and also among different computing devices. So flexibility, yes, you need to know about that. And then the pay as much as you use or as needed kind of concept. So actually, the way things are running right now, it's a prepaid concept. You buy service, and then if you don't use all the service, no problem. If you go over, they charge you more. So, which is kind of not fair if you think about it. But actually, if you think about the growth in the cell phone market and how cell phone services have changed over the years, it's kind of like the same thing that's happening with cloud services. In the beginning of cell phones, we charged per service area. It was per application, and it was per, and then we lump things together. Now we have domestic and international. Now we have voice over IP that gives us everything, and we have all the different types of. Well, cloud's actually sort of done that as well. Why do we subscribe to internet service? If you think about it, why does the ISP even exist anymore? Because we're connecting to a server that's connecting to a cloud for the most part. So that everyone keeps saying, it hasn't happened yet, but everyone keeps saying in the future there's no more ISP. What do you need an internet service provider for? Well, if you think about the concept of tablets and how they're being used, you go to ITU, you connect to ITU's network. You go to Starbucks, you connect to Starbucks network. Problem right now, though, is that the network isn't everywhere. And that everyone has pretty much gotten on the bandwagon and is now providing free service. But you still go to hotels and you still got to pay for service somewhere and stuff. So until everybody provides free service, and until you can guarantee that when you're in your car you have free service, we don't have the capability of selling it like a service, because it's not a service. It's an ISP. It's a service provider. So that's why people actually put 3G on those devices so that they have service everywhere. But the same transformation that occurred with cell phones to begin with will end up having the same effect on the internet. In fact, not so long ago, I think I mentioned in this class already, I think it was the city of Cupertino that decided to have a metropolitan-wide internet service. Didn't last too long. But why should we be paying? Why should we have to connect here when you're on ITU and then you walk outside and you got to connect? Actually, you could probably connect to Adobe outside. if you have access. And then you got to go roam around for another connection and another connection and another. Why can't you just be connected? So until we get there, we're not going to have everything online. So, but they keep saying that's what 3.0 is about. So the Web 3.0, you're just constantly connected, and you don't know the difference between what's on the internet and what's not on the internet. It's all integrated together. So I don't think we're at 2.5 right now. We're not on Web 3.0 yet. But it's a fantasy for most people, computing people. So the question on the final gets into the software as a service. So here's your formal definition of it. It's a model of software development where the application is hosted on a service provider and it's given to customers over the internet. So Microsoft 360 doesn't give you the whole application over the internet. You can't get the whole application on the internet. Nobody's doing this yet. In fact, not even like your Rokus and your Sony players and your game consoles that work over the internet. So it's an application that's installed on a itsy bitsy little piece of hardware. And then the hardware connects and it populates the content from the internet. You know, you lose your internet connection, you lose everything. But it's designed to work with both simultaneously. They say in another 5 years, no more console. No more computer, you just have a screen, you know, and a network card, and everything's on the network. But again, going back to the quality of service, you have to guarantee you have an internet access, which is actually kind of funny because most people think a tablet's pretty useless without an internet connection anyway, and I kind of sort of have to agree with that. What can you do with a tablet if you can't connect it to the internet? You lose your internet connection. So it's kind of waste. I mean, you can read stuff you have on it already, but you can't do anything live. All right, so it's everything that's running from an internet connection. It's generally used to refer to business software rather than consumer software. Falls under Web 2.0 as a technology. Well, that definition's changed. It's now consumer-level software that's running this way. Removing the need to install applications and run on your computer, not quite the reality yet. You still install stuff. And seeing for different ways of businesses to see benefits from commercial software alleviates the burden of software maintenance support. But user replenishes control over the software versions and requirements. Yeah, that's actually said to go away as well. You know, software used to have an expiration date to it, but people install old software. So if you're going to run this and you're the big brother who's delivering the software to the people through the cloud, you're going to control what version they have as well, which means you're going to be in fuller control over updates and stuff too, which is the other kind of interesting phenomenon that we've run into these days. Why in the world are we still updating stuff? The whole concept, you know how much bandwidth that wastes for every single computer to update constantly? You know, it actually takes time and energy, you know. In fact, I turn all that automatic stuff off. And then when I'm bored, I go, okay, let's update the computer. Because I'm not doing anything else, I can waste my time on my updates. But that's like a lot of computers that are receiving downloaded information to update Windows, update the Mac, update software. That's ridiculous. We can get rid of all that traffic 100% by just putting it all out there and we just connect to it. So as soon as we can get that connection working. So virtualization, which is the interesting part. In fact, most people freak out and they go, oh, what do you mean a thin client? Yeah, just a screen. Well, what do you have? You have a virtual disk. It's an itsy bitsy little disk that stores the cache of everything that's running live over that internet connection. Even with the little thin terminals, you have a little bit of a cache system. You have a buffer that's stored locally. But everything else is virtual. So it goes back to the original virtual machine concept with virtual spaces. So you can load virtual machines. So then why do we have a tablet that runs Android and a tablet that runs iOS and a tablet that runs BlackBerry? Why don't we just have a tablet? We can just pick whatever we want to run on it. There's actually, I was at a conference recently, and there's a product that they're working on that's going to do this. It's just, well, it's a tablet. It's a screen and a keyboard. If you're going to run software as a service and you're going to connect to a cloud, you're going to, I want to be an Apple, so you're an Apple. I want to be a Mac, I'm a Mac. I want to be a Windows machine, I'm a Windows machine. Just be whatever you want to be. The hardware is the hardware. So unfortunately, we're not there yet either. That's futuristic. So everyone's saying we have the universal tablet, the universal computer, the universal, it's like everybody's offering the same thing. We can offer the same thing via the virtual machine extraction. And that says we just have hardware and we're running an image on it. And the image today is an iPad. And the image tomorrow we're going to use is an Android system. Which is actually kind of a cool concept. Which you can do through cloud services, actually. In fact, that's how the cable companies are doing it. They have a set-top box. It's made by Cisco. It's not even made by them. It's made by some Motorola, I think, makes those things. They make them for everybody. One of them is a Comcast box. The other one's an AT&T box. And that one over there is a Dish box or whatever. It's all the same hardware. It's all the same thing. They just have different stuff installed on it. And they're connecting to different networks. So why come we can't have a tablet? That's a tablet. What is it? I want to be an Apple tablet. So now I'm an Apple tablet. I want to be a Microsoft tablet. Microsoft tablet. Just switch it. Instead of buying 2 tablets, you only buy 1 tablet now. It's better that way. So actually the people have figured that out, and they do this anyway. In fact, I have Microsoft Windows installed on this computer through virtual machines. So it's the same concept, but we take this virtual machine concept, we extend it out to cloud technology. We separate we'd separate the operating machine, we put the operating machine on the cloud, and then we've got universal hardware. Which means we can take our computer and have it appear on our dash in our car, or we can have it appear on our tablet, or we can have it appear on our computer. That's virtualization. That's part of the virtualization concept. So it's all facilitated through cloud computing. So what is the purpose and benefit? Oh, good question. Convenience? No. So it enables companies and applications and systems to be independent. So it's infrastructure dependent to be infrastructure-less. We have no infrastructure. You don't have to have Microsoft computers and Apple computers. You have whatever it is you need. You have whatever it is you need to have when you have it. And also the infrastructure is a pay-as-you-use or pay-as-you-go. Which is actually kind of an interesting concept. I can't imagine. I probably would have a huge computer bill because I use my computer constantly. But if I didn't use my computer 1 week, I might save some money. If I was paying for the usage of it by how much I was using it. So I actually have a smaller computer that I use to check email with on different days when I'm not teaching. That one never gets used, but I paid the same amount for it as if I were going to use it every day because I bought a piece of hardware. So the concept is you don't buy hardware anymore. You don't buy it. You just use whatever it is you use. It's kind of like cell phone minutes if you think about it. So you just buy 300 minutes if you think you're going to use 300 minutes. So the cost of hardware itself is pretty cheap these days anyway. So how are these companies going to make money on the hardware? They can't. So you can't sell it for what you paid for it, or what it costs you. So you're going to sell services. So we also have today's network-based computing over the internet. Yeah, of course. So now we have cloud sourcing. So why is it becoming a big deal? Well, we actually have crowd sourcing too. Cloud and crowd, now that I think about it. Most people who have been downloading those apps have realized, oh, that's a really cool concept. If everyone's connected and everyone's using something, why not just use the crowd as your resource? It's everyone who's connected. And I think I told you guys about the crowdsourcing app of the blind guy who can tell what something is. It's coming from a bunch of live connections of people who are bored. Actually, I kind of wonder what people do with their phones half the time. They should be putting them to use. Answer some blind guy's question about, hopefully I'm not saying anything politically incorrect here, about what he's looking at, because he can't see it. So he takes a picture of it. And then 2 seconds later, it's a can of tomato sauce. Oh, okay. So then the guy knows what he's looking at. Well, that same concept you can do for sourcing for the cloud. So use a high-scale, low-cost providers. Anytime, any place, any web browser, rapid scalability. So with cloud sourcing, you get, I want this space, and this space. You combine all your spaces together. You put your company, you provide essentially your Salesforce automation over here, your file storage over here, your EMS data over here. You spread it all out over multiple servers, and you source it together with using cloud services, essentially. And can't forget, need to focus on local IT as well. So concerns, performance, reliability, service level agreements. Actually, that's an interesting deal, and that's why we keep switching from Amazon to Rackspace. I should maybe be saying Amazon and Rackspace over a video recording, but long story short, people switch XYZ and ABC companies all the time because one of them goes down occasionally. All you have to do is go down. If you're like a bank and your services go down for a couple of hours, you're probably going to be looking for a new carrier, a new service provider soon. If you didn't just take your application and copy it over to a new one, then go for it, you know. There's also this issue of control over the data and the service parameters, and in the very near future, we're going to have security as a concern. Well, we have a security as a concern right now, which is why cloud services have slowed down. You're not going to stick your business, your personal business information out for the entire public to see. Not going to do it. So a lot of businesses have slowed down their adaptation or their transference to this cloud because they just don't want to risk it. It's not worth the risk. So use older technology until it's secure. So once the security comes into place, we're going to have some interesting controversies, just like we do with other applications that support this, but this service doesn't support that. Well, we're going to get, this is the level of security you're paying for, and this is what you're going to get. And then here's the plan, and you have to pay more for security for the most part, which is kind of interesting. Also the mix, the standard APIs. So there's no standard API, but there's a mix of things that are being put together. Privacy, security, compliance, trust. It's a big one. So here's some commercial cloud offerings that we have out here today. This is probably a little bit outdated. We have a little bit more. Newer companies have popped in. Problem is commercial offerings are proprietary and usually not open for cloud systems research and developments. Now, you're stuck with what you're getting. And you don't necessarily have full capabilities as if you had your own server. So a lot of companies are actually creating their own clouds. There's cloud software. You buy a bunch of servers, you install them, you turn them on, you install the cloud software, and voila, we have our in-house cloud. Not a bad option, actually. And then you can sell services to other people if you wanted to, or just keep them yourself. But you got to be a big enough company to afford the server technology and the expense of it. So here's just a little bit on the taxonomy, which is basically the separation of the cloud software, the software we're going to use on the platform, on the hardware, along with the infrastructure, the services themselves, the servers, the computing services, and then, you know, look with the platform itself and what we're going to offer. This is Open Crowd as an example. So. And then we have cloud storage. We use cloud storage, actually. That's what we're doing here. Every one of your assignments that gets uploaded is saved. Imagine what would happen if we had this on a private server. We have to keep growing the server every semester because we have new students. And we don't delete anything, we just save it. And then we save it, and then we save it, and then we save it. And then we have more and more students who come in. And then we just keep saving stuff. Well, we need cloud storage. That just grows unlimited. It's kind of like how people experienced this themselves when they started downloading music and videos. And then I need a bigger hard drive. Well, I need a bigger hard drive. I need a bigger hard drive. So it eliminates the concept of there being a hard drive, so we don't have to worry about how big it is. So Amazon, Google, exploiting the fact that they have data storage capabilities. They're hired out to others to use. So it's cloud storage as a concept. And here's our web services. So you can actually get into this as a technical person, programming for Amazon Web Services. There's API, so each one of the web services for each one of the individual companies, and there's differences between what they're offering, will provide API level support. So you can build your application to work with the cloud. Huge part of mobile development these days because mobile development's all cloud based. What do you get? You get 8 gigs on the device. 16 gigs on the device. How are you going to share information between multiple devices? Impossible without cloud services. How are you going to take advantage of email services, text messaging services, all these other things? Well, you have to connect to their cloud services. So what do? You download the API, use the API in the application development to create your application, make it cloud aware. Get cloud. And a lot of these actually have separate cloud platforms that are shareable among different application developers. So a lot of the Android stuff through Google Play is all cloud stuff. So we have a bunch of utilities that are supported through Google Play. Amazon Simple Storage Server, S3, because we have 3 S's in there. Simple Storage Server Service, excuse me. Unlimited storage, using same scalable, fast infrastructure as Amazon uses. So we don't have that problem with, which is actually kind of interesting. You know, it's actually sort of the same thing people get when they get storage units, which is kind of a phenomena, and I never really thought about that. And for some strange reason, I looked at this picture and the thought of a storage unit came into my mind. So you move, you fill up a storage unit, and then you buy new furniture, then you move again. This is what Americans do. Foreigners, I don't do this either. I don't fall into this trap. And you pay, what, $100 a year, let's say, for your first storage unit. And you keep it. It's full of crap you'll never use, but you keep it. And then eventually you move again and you go, I have more stuff. So then you put it into a storage unit. And then you pay, oh, now it went from $100 to $200 to $300. The storage unit gets bigger and bigger and bigger. The crap just piles up. Bigger and bigger and bigger. Until one day you just like, why am I paying a monthly bill on that? And the most that you've been paying for all that storage throughout the entire 5 years of keeping it doesn't equate to the value of what's inside of it. So you walk away and you decide you're not going to pay the bill anymore. You just leave it alone. It's free garbage removal. And this happens every day. And then you go to an auction. You find this on the internet constantly. You can buy people buy storage units because people abandon storage units. So you buy a storage unit. What are you buying? You're buying somebody's crap. How do you even know what to, they don't even let you look at it, or they open it up for 5 minutes. Here, look. Okay, shut the door. How much you want to give me for this? And you're paying like, I don't know, something really small, I hope. I've never bought a storage unit before. But this is big business. And then they go to flea markets and they sell this crap. And I'm thinking, why do this? This is what we're doing with our data right now. So just think about all the crap we're storing that we don't necessarily need to store. I think we have attendance starting, so I'm going to switch topics and put this on hold. All right, so I was talking about storage units and comparing it to cloud computing, which is very similar, actually, what's going on these days. So instead of selling the data, we're selling access to the data. So we have the same concept actually happening. People are buying access to data so that they can use it to find out what's there. Because there's some sort, I know, we have so many conversations going on. I'll just wait. Hello? Thank you. So they don't know what they're getting, but they're buying it, which is kind of an interesting concept. It's turned into a lot of data mining applications where the company just gives you access to it for a price, obviously. And then other companies see, well, what kind of data is this? What's in here? What can we do with it? Or do we have other data mining activities that are just using clouds in general to accumulate information? So data mining as an industry has become very popular due to cloud computing because we're sticking all the data out there, we're putting it all together, we're sharing it, we're making it available. Yes, we're taking advantages of weaknesses in security and weaknesses in access. But at the same token, we're making new applications out of it. So we're able to share information, even though you may not necessarily think that your private information is being shared because your account, as an example, is allowing you to have some security, which is kind of the same concept with Facebook, actually. They think, well, I'm not sharing it. I have this restricted. I have these settings made so that they're not this isn't happening to me. But it is happening to you because the storage location where the data is actually being stored is being shared. So it's not being shared from an application perspective, it's being shared from a data storage or from a service protection that's missing or that's not somebody didn't design it properly from the beginning to make it, and then there was no way, and it's nobody's fault because there's no way of designing it properly. So that's one of the problems we're having right now. And it's going to slow down the use of clouds in general for the long term. Because as soon as there is a security issue, we're going to end up with a problem with, well, people don't trust it anymore. If you don't trust it, you're not going to use it. So, all right, so this lecture goes through several different examples of different services. I'm going to thumb through it and not really talk about them because they've all changed their services within the last year or so as technology improves. We still have utility computing, that's the EC2. The S3 is that storage service concept that we're looking at. Utility computing started way before cloud, and cloud actually ended up becoming a part of utility computing in general around 2006, where we have that powered by a virtual machine, and we have virtualization, so we have stuff stored in different formats that's all stored together, but it's more of a utility, using a platform as a utility instead of using it as a, well, when you think about it, the computer is now an appliance anyway. It's a utility. So it's like using a calculator from the beginning. So load your images on it, register for it, put your image into the web service, open it up the required parts of the image, use the image as a virtual machine. The virtual machine is running on a cloud. Long story short. So it allows you with the virtual machine kind of concept. And then connect to the image through SSH, secured hosting, or secured connection, and then execute your application, run your application. Actually, this is sort of like how ITU is running the EMS, actually. It's run through a utility computing service where we have an application, we install it out there, we load a virtual machine up that's running the platform, and we connect to the platform. And the platform is being available through a web hosting environment. So you go to ems.itu.edu. Notice you don't go to www.ems.itu. In fact, if you type it in, you get an error message because there's no www address for EMS. It's a cloud service run through a virtual machine from a hosting environment. It's ems.itu. It's not World Wide Web, which is interesting. It's an application, so, which is interesting. Most people don't realize that. They've been using it for forever, and they go, "Oh, I thought it was a website." No, it's not a website. We have Amazon, Elastic, Mapreduce. Well, I'm not going to go through Amazon's and Hadoop and any of the other ones. Hadoop's pretty popular, actually. Most people are familiar with that, actually. It's a Java framework, so. Nah, a little beyond the technical ability of this course in terms of what we're supposed to be offering here. So, instead, I'm going to focus on opportunities and challenges and conclusion of the app. I was going to say app development, cloud development, and cloud trends. The use of clouds obviously is on the rise. It provides a number of services, a number of opportunities from a business perspective. And here's some things to think about if you're going to answer this question. So the no-brainers. Think about cloud technology, review this lecture on a slower pace. And then you have one of your answers for your final covered, because one of them is going to be on here. And then say, let's talk about challenges, or let's talk about opportunities related to this. Using our, basically enables the service to be used without understanding their infrastructure. Actually, you can have a lower level IT person actually design and implement all your IT services. You don't need highly trained technical people on staff. What you need are people who are familiar with the technology, but they don't have to implement it. Instead, they're renting it. So this kind of gives you a better advantage. You can also have economies of scale, as I mentioned earlier. Start small and then grow the computing services. So you have lower expenses up front. You don't have to buy the hardware. Sometimes you do have to sign up for contracts and provide an agreement that says you're going to do this for a year. It's kind of like how you sign up for cable or how you sign up for phone service. Well, they get you at the phone because they sell you the phone, and then they sell you 2 years of service. You add up what it costs for the 2 years of service, it's usually more than if you just bought the phone. But who wants to just buy the phone for $800? But over the next 2 years or 3 years, you're probably going to be paying $1,000 instead of $800. But you're getting the phone service free. But what good is this phone without the phone service? And the phone service is actually pretty cheap these days compared to the price of the phone. So, anyway, long story short, it's a big business in terms of the way you're going to market this product. Cost would be on-demand pricing, and the data and services are stored remotely, but accessible from anywhere. So you have the remote access that you get from everywhere. Also, not mentioned in here, or maybe just mentioned coming up but not mentioned yet, is the fault tolerance. So your systems are never going to go down. If the building catches on fire, which actually nobody thinks about that actually these days, but buildings do still catch on fire. They also flood. They also, they catch on fire and then they flood after that because the sprinkler systems come on. And then you put sprinkler systems in your computing resources room, which they don't think about because we have non-water fire protection. People don't realize that until after the fact. And then your server goes down, well, you've lost everything. So you don't have that with cloud services unless the cloud company goes down. So unless you have a bombing and the building goes down or something, you're not going to lose your cloud services. Even so, they have it backed up on so many different networks. You just connect to a different network. Oh, this one's down. Connect to that one over there instead. Which is why, you're never going to, you're going to have anything down because you have fault tolerance and you have replicated and duplicated servers all over the place. So in parallel, there's also backlashes against the cloud computing. Use of the cloud means dependence on others. That could possibly, here's some challenges for you actually, could possibly limit your flexibility and your innovation. You don't pay your bill, all of a sudden, hey, wait a minute, what happened to our computing services? Down, which is kind of the problem with personal, consumers using cloud services. Your students, and I don't know about you, but most students don't have a lot of money. So usually the traditional student is spending money for tuition, and they're spending money for rent, and they're limited, especially in the U.S. So you have a paper that's due, and you write it through your Microsoft 360, and you save it on your cloud, and then, oh my God, I didn't pay my bill on time, and whoop, they stop my service. I can't turn my paper in. It's not because you can't turn your paper in, you're going to fail the class, it's going to cost you tuition, and you still can't pay your service bill after that. Long story short, it's the better excuse than my dog ate my homework. My cloud service provider decided to discontinue my service is suspended. I'm sorry, I can't give you that paper this week. Which actually would be a true true excuse, I guess, for some people. So interesting. Or it's like the pay-per-view that you didn't pay for and then you can't view it. Or whatever it is that happens to be it. Also security, more so than paying your bill, it's the security that people have an issue with for the most part. So if you can imagine to pay your bill, someone might steal your paper. So, which is actually kind of interesting because that's kind of like the concept behind turnitin.com, but that's on purpose. You turn it in, and then it becomes part of the database. And then they want you to turn it in, so they promote it. Oh yeah, check it, see if it works. The funny thing is the second time you check it on the same paper, it's plagiarized by you. So, which is not such a good thing, but people know that, so they don't do it multiple times. But if you put your paper in there, somebody else put their paper in, connect all the schools throughout the entire United States and put all their papers in there, you got a lot of similarities to go check against. Especially if one person downloaded it from the internet and turned it in to turn it in, and it wasn't there before, but it's available on the internet, somebody else does it, gets caught immediately. So it's a great service, works on cloud technology, works on comparing, but it goes against the concept of there being security. It works with the fact that there is no security. In fact, the whole system is not designed to be secure. You put it in there and the whole world's going to read your paper eventually because they're going to, especially, your paper's known to everybody. So they're doing it with dissertations now too, which is really good. So make it so that you can't plagiarize or copy somebody else's stuff. So there's also issues related to policies and access. Not only not being able to access it, but the data is stored abroad. So maybe it's not stored in the U.S. Do we have to store it in the U.S.? We don't. Well, then take it out of the country. Then if it's outside, then are we going to adhere to legal policies and regulations that cross borders? Probably not. So your banks aren't going to store stuff out of the country. They're going to store it in the country. And then what about access to it? What happens if the remote server goes down? What if you can't access those files? You can't access the data. So going back to some advantages. So the challenges and the opportunities and challenges, of course, the opportunities outweigh the challenges at this point. It's not until one of the challenges becomes a huge issue that we're not going to stop using it. So in terms of advantages versus disadvantages, well, the big advantage is the lower cost. It's cheaper. Lower startup costs. Big companies, huge companies, don't have to worry about this, but little small companies, mama papas, can now compete with huge companies. It's equal. It's an equal playing field now when it comes to the resources. So you don't need to pay higher powered, higher priced computers. You don't need anything actually. In fact, you don't even need a PC these days. You just need connection to the internet. Improved performance, obviously. Faster working computer systems, bigger platforms, faster bandwidth. You also have improved, you have larger computer memories, larger computers. You have I don't think we could actually put our EMS on a non-cloud service right now. It's too big. We don't have a hard drive big enough to load the application on it. They don't make them that big. So we have something that spans that exceeds the capability of a PC or of a single server. So it's really hard to go backwards. You can actually say that's probably a disadvantage. You got a system that you can't downsize. Well, until we start archiving it. And I believe they're starting to archive it. Take the stuff out. They're going to need to start taking stuff out soon. Otherwise, we're going to get stuck in a situation where we can't downsize if we need to downsize it. Why do we need to downsize it? Because we want to move it from one provider to another, or we want to better manage our disk usage or our service space. So going back to the advantages, reduce software costs. We don't have to pay as much for it. Instead of purchasing expensive software and applications, we just use as we go. And they're sort of free-ish. So there's right. Most computing platforms today, Google Docs, etc., are totally free. Most of your computing software is free. Actually, most of your cloud software. You don't have to pay for Google Docs. You don't have to pay for Gmail. Gmail is free too. There's a reason why it's free, however. There's no expectation, there's no requirement, there's no rights. You're using it at will, and you're using it for free. You're not being charged for it. Which means we don't care about your security. We don't care about what we're doing with your data. We don't care about people buying it. You know, it's like going back to the entire concept of the storage unit. You gave it away. You stopped paying the bill. Therefore, you don't have any rights anymore on it. So we can go ahead and sell it for you. Instant software updates. No need to update software. The server's updated instead. Improved document format compatibility. I'm hoping Google Docs actually improves that. It is improved right now. We can store Word, Excel, PowerPoint all online through Google Docs. But I'm seeing some problems with compatibility for the most part. So that will probably improve over the years, but we've gotten a long ways, so now it is compatible. You don't have to worry about the documents that you're creating not being compatible on multiple operating systems or multiple platforms. If you create them and you put them out there, anyone can access them. That part is valid. You can access them, but when you download those docs and you try to use them in native applications, then there's a problem sometimes that I find. Only because, not here, but at another school, students actually try to submit Google Docs to me as assignment submissions. Here, everything gets uploaded into EMS. That's not really a problem, but elsewhere they send me a link. I log into the link, and there's nothing there. And I wonder, well, why is there nothing there? And then I can't give them any points for it because, well, they moved it, or I can't read the file format, or I downloaded it and I can't get the download. The file is empty. I can't get it. So don't submit assignments with Google Docs. You can't do it anyway for this school, but if you're given the opportunity, it's just another opportunity for there to be a problem. It's like how people put stuff out on the web, or they get, here it is, it's out there. Well, how long is it going to be out there for? And when I get it, it's not there. So also unlimited storage capabilities. Cloud computing provides unlimited resources, unlimited bandwidth, and also unlimited resources. So 200 gigabyte hard drives is small compared to hundreds of terabytes of drives out there on the cloud. And whatever you need to store, you can store it. And for as long as you want to store it, actually. And you don't have to worry about a hard drive breaking either, actually. And increased data reliability. No hard drive breaking. Unlike desktop computing, hard disks crash all the time. They get destroyed. The best way to destroy your computers these days actually is to, well, if you really want to hose somebody's computer, open up the back. If they have a solid state drive, open up the back, take away the, it looks like aluminum foil, but it's a protective coating on it. Take the coating off, put the hard drive back in, seal the computer back up. They won't notice it. It's inside the computer. How are you going to notice that? This has actually happened, and then someone said, well, isn't that against the law? This actually happened, and then you take the computer and you go and it happened to a business traveler, and the business traveler takes the computer and runs it through the X-ray machine. Empty. And then he wondered, no, I'm sorry, I'm lecturing. I'm just being animated, I'm sorry. No, we're not done yet. I'm still, oh, thank you.
After 4, right?
After we finish the class, I'll give you the file.
Right.
Yeah. Long story short, all the data on the disk is wiped out completely. And this comes into the legal system, and the guy says, well, I'm going to sue you because he took it to the computer store to figure out what's wrong with my computer. They open it up and they go, oh, somebody took off the insulation on that disk. Long story short, the data is unreliable because the disk was unreliable, but somebody tampered with it. Long story short, the guy makes it to the meeting, but the computer's empty, it's unusable, yada yada, can't deliver a speech, loses a sale, loses business contact, you know. It's another trick, so they were suing for opportunity loss or suing for damages associated with somebody doing that. But you have to prove that someone did that. How are you going to prove that you took the cover? How are you going to prove that you took the insulation off the disk? If that were stored on a cloud, you wouldn't have that problem. You're not going to have the same problem. If you're using cloud computing, the reason why I mentioned the example, you can't lose your laptop. You can't lose the tablet. No one's going to tamper with it. The airport's not going to ruin it. Tons of people claim, you know, oh, I was going through airport security and I dropped my notebook. You know, okay, so if it's loaded on a cloud, you don't have that problem. So, increased data reliability, long story short. Actually, I put everything online, behacker.com. It's on a cloud actually. It's on an internet server. I never have to worry about losing anything. And then I take it, and it's been going on for a couple years right now, actually. I have stuff archived back from when IT was in Sunnyvale, all on that same server. Students often send me messages, and they go, hey, you got that syllabus from that old class I took? Sure. Go out to that website. It's out there. Oh, okay. Actually, I'm not supposed to do it, but it's for the RFEs, you know, when they request for evidence. I always get an email message. I say, hey, just go out to that website. Well, it's a benefit. It's reliable. I don't have to. What computer was that on? Back 2 years ago when you took that class with me? I don't know what computer it was. And actually, the sad part is they're supposed to be going to the EMS for it, but it's not in the EMS either because it's not archived correctly. How are you going to go back in there? Term's over with. You get access. Well, now you finally get access to the previous term, but prior to that change, you don't get access to anything anymore. So, anyway, long story short, we could make it more efficient by giving an archive of all that information and providing it, because it is a cloud, it's out there. So, giving students access to it past its use, well, it could be a pro and a con, could also be a business policy. When you leave a company, you're not supposed to get access to the company resources either. So, from an employee perspective, it's business rules that you're enforcing. More advantages: universal document access. Having one document shared among multiple different platforms and things. So it's not a problem with cloud computing because you're not taking the document with you. It's available everywhere. It's kind of like it's behacker.com. Everything's available to everybody, anywhere. So instead, they stay on the cloud. They don't stay on the computer system. Also, latest version availability as well. You can get multiple different archives of different versions of different documents generally if it's stored on the internet or on a cloud. And you can edit documents from home. You can edit it from everywhere. Actually, it's kind of funny because I update that file actually that I put up for the final exam review. Came from my Android tablet actually. It's funny because it looks like it is a Microsoft Word document, but I uploaded it from a tablet that I was working on while watching TV last night actually. I did it last night while watching television from a tablet. But long story short, you got it. Look, I got it. I got it today. It's up here. So it worked. So, well, people work remotely. People work from their living rooms. People work from their offices. People work. You guys are doing stuff here on your computers. Who knows? Who cares where it comes from or why, when it happened? If you put it on a cloud, it's updated. It's out there. So cloud computing provides you with that option. It's also device independent, as I mentioned before. So yeah, I did it on a tablet computer, an Android computer, and it worked. It's out there. I access the site the same way as I access it from my MacBook or from a Windows machine or something like that. No longer tethered to a single device or platform. Disadvantages of cloud. Those are all the advantages. Well, it requires instant internet connection. Yeah. If I don't have a home Wi-Fi system, it's really going to be hard for me to work in my living room. I have to go back to the office to tether to a wall to plug in my computer if I don't have a Wi-Fi system. What if I don't have internet at home? I work for a company and I only have internet access at work. Then I got to do it at work. So Requires the access. Also, cloud computing is impossible if you cannot connect. Yes, it is. In fact, you're going to have the same problem. You leave today, you come back and say, well, all right, she told me to prepare all these answers. Website's down. Oh, bummer. I can't get to all those lectures that are out there. Oh, my computer's not working. Oh, problem. You can't get to the internet. You're not going to be able to prepare your answers. So, a dead internet connection means no work. And in areas where internet connections and a few are inherently unreliable, depends on where you live. We happen to be spoiled in the state of California. Other areas, you don't have Starbucks on every corner. You don't even have a library. Well, actually, we don't have libraries. Other areas, they have libraries. And students go to libraries to use computers because it's not reliable at their home. Or it's not a very fast connection. So here we have DSL everywhere. I hope that was a child and not an adult. We have internet connection everywhere. We have high-speed access. We have DSL, cable modem service. We've got tons of options. You got Alaska, you got 56K dial-up service if you're lucky. You don't have everything. So, and I happen to know that because I teach in another school in a distance learning environment, and a lot of them they live in Alaska, and they can only connect at certain things. It takes them like an hour to upload something that would take 2 seconds here, or to download something. So you have to be wary of like how long it takes someone to download something, whether they can or not. So that's what I say. And the biggest disadvantage I see for cloud computing is not everybody has that high-speed access. You can't stick software out there and expect people to get it that way. So you might be laboring with low-speed dial-up connections. And yes, parts of the world still use dial-up connection. In other words, cloud computing is not for broadband impaired, as that last bullet point says. You cannot be broadband impaired. In fact, even now, I'm finding I need to upgrade my broadband service. If you install a smart TV and you have the internet on that, and then you have the internet on your tablets, and you have the internet on your computer, and then you're running voice over IP, you pretty much have used up all your bandwidth if you're on a basic package. So then you have to determine, well, what all those things are really important to me, and do I want to upgrade my bandwidth? I think I need to go cable modem, actually. But anyway, long story. Google Fiber? Yeah. I need to go fiber. Yeah, but you know what? I'm too cheap. I'm not going to pay for it. I have basic everything. So I'm not going to pay. You know, you add all that stuff up. You know, you live in California and you got all this technology. You pay like, just for the cable alone, it's over $100. And then you got your cell phone service, your smartphones. You made like $300 or $400 a month just in internet stuff. So, not to mention, you know, Netflix. Yeah, $10 a month. That adds up. You add that on with Amazon Prime, or you subscribe to Vudu or something, and you buy the movies and stuff. All that stuff. You end up spending a couple $100 a year on that stuff. So. Well, probably more than that. I use it conservatively. There's people that use it and put the kids on that. Way expensive. You got to turn all those services off. It's like $10 a movie, $15, $20 a movie. And they sit there and they watch 3 movies. And half of it they don't watch it. It plays while they're doing other stuff. That's too costly. Disadvantages also. So, not to get into the buying habits of consumers, but can be very slow. Yes. Actually, the more people, in fact, this happened in America in California, I should say, in growing areas of California back when the housing industry, they started building more houses, and then DSL used to be really good service. Now it's really bad because everybody's on it, everybody's using it. The more people get on a network, the slower everything is. Same thing happens with cloud services. The more people use it, slower the service gets, poorer the quality. So even a fast connection, a web-based application can sometimes be slow depending upon the software platform and how many people are using it. Everything about the program, the user interface, the graphics, and everything might go back and forth between an internet connection, and it might actually be slow. Features might also be limited, especially if you don't subscribe to the premium service, which is actually kind of interesting. Now this thing called basic, limited, and premium came out of it, you know. So we have qualities of service that you can pay for or don't pay for. So features might be situated in terms of a situation that's bound to change. So we have web-based applications that have full feature sets for desktop applications, but limited resource sets for mobile devices or limited resource sets for mobile computing. It's like what they did with Windows 8. We had the RT version and then we had the full version. Actually, Windows is interesting case study. I'm waiting to come out on this one. They tiered the services for cloud-based compatibility, and then they discovered that it didn't work. Nobody likes RT. It's stripped down. You can't install anything on that operating system. You can only, now we don't have it. Now actually the new Surfaces that are coming out are not RT, they're full Windows. In fact, it's not the Windows Pro, it's the other version of Windows. That's a hybrid between what they thought people would use and what people actually want to use. So it's limited, but it's better than it used to be. You can actually install stuff on it now. Actually, there's a couple new versions of Windows 8 coming out as well within the next month that are much better, much more improved, because they made it more powerful. They made it less limited. And they took stuff off the cloud and they put it back on the operating system. Because I think they were just a little bit before their time, actually. It was a little too fast. Consumer market wasn't ready for it yet. So anyway, so we have Microsoft PowerPoint, Google presentations, web-based offerings and stuff like that are different. So storage data might not be secure. That's a big problem right there with a disadvantage of cloud computing. And the question is, how secure is the cloud? Not secure. There's no expectation of privacies on the cloud. And storage data might also be lost. You're a big company and you're putting your data in the hands of somebody else. Are they going to do the same job? Probably not. Are they going to keep it secure? Probably not. Is a virus going to come in and take their system down? Probably. And are they going to go out of business? Probably. And your entire accounting is given to somebody else, and now you've lost it. So that's why you go with a bigger company, and the bigger company knows that, so they're going to charge you more. So you pay a significantly higher amount of money to go with a name brand cloud service, with the expectation of them not going away, which makes the barrier to the market impossible. No one's going to hire a low-end, no-name, I'm brand new company to do all your cloud services. Even if they charged you $1 a month, you're not going to do it, because it's not worth it. General concerns, different protocols, different APIs. That's the other problem. Going in, this is the general concerns category here. You're building your applications to work with this platform, and what if this platform is not standard? Then how are you going to be able to move it to another platform? You can't. Which is why people originally decided to build applications for Windows, because Windows was more general. So if it worked on that, then it was great. They didn't want to build for Apple, or they didn't want to build for other platforms, because who knows what's going to happen. So you build your entire applications to work on certain platforms, and then the platform changes, platform goes away. Same thing happens with cloud services. You design the entire infrastructure to work a certain way, and then new technology comes out and makes it obsolete. And then now you're working with old technology, or you can't move it. You're stuck because it works with a certain API on a certain platform. So in conclusion, and yes, I'm getting there, the future of this is that most activities are loosely grouped together under cloud computing, and it's a very generic word, and it's very generalized, and now everything's the cloud. Well, in reality, we have grid computing, which is the latest research-led centralized approach. Well, grid's been along long before cloud computing came around, but now everyone's talking about grids. And it's like, well, because the meaning of the cloud has been washed out a little bit, so now they're coming up with new buzzwords to come up with new things that are really just old things that are resurfacing. So concerns on mainstream adoptions of the cloud has slowed people down. Security is mostly the biggest problem. They worry about whether it's grounded, whether or not, whether or not they should rely upon it. And then many open source systems are appearing that get installed and that run with local clusters that kind of take away those problems and make it a little bit more secure. So for the most part, we got big with cloud computing. Now we're getting privatized. We're having smaller, more secure cloud environments with specialized services and features to take, kind of take those take the disadvantages away from the big companies, or take from the big industry and make it small and privatized again. So anyway, that one was lecture number 17. It was the last topic for this class, which was cloud computing. There is a question on the final exam that comes out of here. I went through this on the fast side, so believe it or not, this is about 42 slides, but you can read through it a little bit slower in order to really do well, and to just as a final statement about the final exam. You can go off of what's in the lectures, but the lectures are very high level, very summary. You might find it useful and it might pay off for you if you do a little bit of research. Where are you going to find the research? Probably on the internet, journal articles, books, pieces. Go for it topic by topic. I gave you the topics. Find 5 or 6 of them you like. Research the topics. Get some background information on it as ammunition. You come in, you're going to see questions on those topics. Answer the questions, and then you'll ace the exam. All of the assignments are due on the 22nd. I'm going to see you next week for the final, but after that we're over with. But on August 22nd, everything is due. I'm waiting till the 22nd because the EMS doesn't tell me what's been graded and what hasn't been graded, so I can't go in and change stuff after I grade it. So I usually wait till after the day after the due date. So on the 23rd, I'll go in and upgrade the grades for everything. If you have a question about something before you turn it in, before the 22nd, send me an email. If you send me an email on the 23rd and you say, is this good? I can't do anything for you because you can't submit it anyway. So if you want to pre-test it to see, am I going to get full credit for this? Is this good? I'm not going to grade it for you, but I can tell you whether it's good before the 22nd. You don't have to. If you're confident with it, upload everything by the midnight on the 22nd. On the 23rd, all the grades are probably going to be posted instantly, because then I can go through and I can update the whole system all in one shot and get everybody's, so without forgetting anybody's, which hopefully it won't happen that way the next term. We'll have more features for the grading component, but right now it's kind of stuck in a batch mode. So questions, comments, concerns? You don't like Monday, come Wednesday. If you come on Wednesday, come at 11 o'clock. All right, we're done for today. Thank you.